Recording. Students will be able to find the velocity, acceleration, speed, and position of a particle. Definition is displacement and distance traveled. Well, they're telling you that the integral of velocity is displacement. We already know that. We know that. But now you have the displacement for the x-coordinate and you have the displacement for the y-coordinate. So now they're just separate. That's the only thing that's really new in here. And then we've talked about how the distance traveled is, if you have this curve, you're going to do change in x over change in y, or change in y over change in x. There's change in x, change in y. And you could estimate, I should have had it up there. You can estimate the length of the curve with all those little hypotenuses. So we're doing the Pythagorean theorem on the change in x and the change in y, but if you apply that to movement, the first derivative is really velocity. So that's the same thing. Saying do it on velocity is the same thing as doing it on the first derivative. The velocity v of t of a particle moving on the plane, in the plane, is given, along with the position of the particle at t equals 0. Find A, the position of the particle at time t equals 3, and B, the distance the particle travels from 0 to 3, the position of the particle. Initial position plus the displacement is equal to the final position. And I think about that equation not so much going forward, because I know that if I'm given the position at 0, what's the position at 5, I integrate from 0 to 5. But I use this more when we're going backwards, when they give me the final position and they're asking for initial position. Now I know to minus over the displacement. So I use that more for going backwards. And we'll practice some of those. I don't think today, but later. All right, well, this is the position when t equals, not 3, excuse me, when t equals 0. We're going to go forward today. So it says, A, find the position at time t equals 3. So S of 3 is equal to the position at 0 plus the integral from 0 to 3 of e to the t minus t dt. And then also 1 plus 0 to 3 of integral from 0 to 3 e to the t plus t dt. So that's just going forward from the position at 0 to the position at 3. And that's what they want, position at 3. Let's do this real quick. E to the t minus 1/2 t squared from 0 to 3. And then 1 plus e to the t plus 1/2 t squared from 0 to 3. One plus e to the third minus 9/2 minus e to the 0 minus 0. E to the 0 minus 0. Comma 1 plus e to the third plus 9/2 minus e to the third plus, wait, not e to the 0, e to the, e to the 0 plus 0. I got it eventually. Oh, that's 1. 1 minus 1. So this is just e to the third minus 9/2. Some decimal value for that. We don't care what it is. And I think we get 1 minus 1 here. So we get e to the third plus 9/2. And there's some decimal value for that actual position, but we'll call that good. And then B, the distance particle travels from 0 to 3. But this is the first derivative. This is the change in x and the change in y, essentially. So we're going to go integral from 0 to 3 of square root of e to the t minus t squared plus e to the t plus t squared dt. And there's some decimal value for that. I'll assume you know how to plug that into your calculator. A particle moves in the plane so that position anytime t is given parametrically by those two, sine of t and cosine of t. A, find the velocity vector for the particle. So v of t is equal to cosine of t, comma, negative 2 sine of 2t. So we take the derivative. There's the velocity vector. B, for what values of t is the particle at rest? Well, that's when cosine of t is equal to 0 and negative 2 sine of 2t has to equal 0 also. Now, if a particle is at rest, it means it's not moving. But if the x-coordinate is 0, but the y-coordinate has a value, that means it's moving up or down, straight, it's moving vertical. If the x has a value and the y is 0, that means the particle is still moving horizontally, right or left, with no up and down. So in order for the particle to be perfectly still, both of these have to be 0. So t is pi over 2 and 3 pi over 2 for cosine. If we divide by negative 2, that doesn't really affect what the zeros are. That's still 0. And then 2t is equal to 0. Sine is 0 at 0, at pi, at 2 pi, at 3 pi, and at 4 pi. Now I know to go all the way to 4 pi because when I divide by 2, that'll end up being 2 pi. We're going 0 to 2 pi right here. That's what it says right there. So t is 0, pi over 2 pi, 3 pi over 2, and 2 pi. So both of these values show up on both lists. So the particle is at rest at pi over 2 and 3 pi over 2. Both of the coordinates are 0 for the velocity. They both have to be 0. That's the whole point of that one. And then letter C. Write an equation. Well, we have this one right here and this one right here. And I got to eliminate the t. But if this said sine of 2t would be fine. They'd be exactly the same. And we'd have x squared plus y squared equals 1. We'd have a circle. No problem. But they're not the same. But we have this double angle right here. So we can write the cosine of 2t is equal to, and we have 3 choices for this one. We're going to go 1 minus 2 sine squared of t. That's the double angle formula for cosine. Well, this one says cosine of 2t is y, and sine of t is x. So there's where you get that parabola. This is an upside down parabola. There's the equation for it. D, sketch the path of the particle. We already did that for you. We use calculators for that anyway. Any questions? All right, let's keep rolling. The particle moves in the xy plane so its position anytime t is given by x and y. Sketch the path. Let's do that. Grab your calculators if you want to play along. All right, so we're going to go to parametric mode. Hey, mode, parametric mode. Go to y equals, and we got t squared divided by 2 minus natural log of 1 plus t. There's the x. And then 3 sine of t. And I kind of gave a hint as to the window for this. This is, we'll see if it fills the window. with 0 to 2 pi. And actually, -3 to 4 is a good one. -3 to 3 seems to be fine for the y. So I went from -3 to 4, seemed to fill the window. Let's see what we get. Graph. All right, so we got something like that. Oh, did I go from 0 to pi? Window, that's 0 to 2 pi. 0 to pi. And it kind of, that'll stop it on the x-axis. There we go. Indicate direction. Seem to be going in this direction from left, kind of right to left and then left to right. At what time t for 0 to pi does x attain its minimum value? What is the position of the particle at this time? When does x attain its minimum value? All right, so let's go x prime of t is equal to, well, that's 1/2 t squared. So t minus 1 over 1 plus t. There's the derivative, and to minimize, we set that equal to 0. So let's add that over. Now we're trying to solve this. Here's algebra now. Multiply by the bottom is what I would do. T plus t squared. So there's multiplying over the denominator. Set this equal to 0. Well, now we're really going to bounce back and forth if you're going to play along with your calculator. We're going to go from when we have to do parametric, or do parametric. When we have a single equation, we're going to go back to single equations. Well, now here's where we are, right there. We got to go back to a function, because now we're not solving a parametric, we're just solving a single equation here. And so this will be in x's, but I mean, we don't care what the variable is. X squared plus x, x minus 1. And we're going from 0 to pi. So the window should be 0 to pi now for the x value. Let's graph and see what it looks like. There we go. And we get that 0 right away. So we're going to calculate a 0. Hey, where are we? There it is. Come on. Here, there, back up, boom. 0.618. So t is equal to 0.618033399. And it says, at what time does x attain its minimum value? I got that, but what is the position of the particle at this time? So now we got to plug those back into here. But the good news is x is holding that value. So I can quit out of here, go x squared divided by 2 minus natural log of 1 plus x. So the point is negative 0.290, and now I just need 3 sine of x, and we got it, 1.738. There's the point. There's the point. I think we got something down here. Yep. At what time is the particle on the y-axis? Find the speed and acceleration vector of the particle at this time. At what time is the particle on the y-axis? Well, that's when x is 0. When x is 0. 0 is equal to t squared over 2 minus natural log of t plus 1. That's when we're on the y-axis. All right, so we got to go to y equals, clear that out, x squared divided by 2 minus natural log of t plus 1. Now look, it doesn't include 0 and it doesn't include pi, so somewhere in between there. So if we graph this, there's the 0, so it's on the 0 at 0, but then there's the other intercept right here. Here's where we're on the y-axis. So we're going to go calculate a 0. Oh, where'd it go? Why'd it go over there? Oh. There. Left bound, got it. Right bound, got it. Back up. 1.285. So t equals 1.2858887. Find the speed and the acceleration vector. All right, so this is where it crosses the y-axis. Now I need the speed. Speed is the magnitude of the velocity vector. It's the magnitude of the velocity. It's the length of the velocity vector. The vector tells us direction, and it tells us how fast it's going. We want to know how long that thing is. Square root of. But I have the derivative of x. That's the derivative of x. T minus 1 plus t squared plus 3 cosine of t. So 9 cosine squared t. All right, but we have the t value. The t value is sitting right here because I just calculated it. So I don't have to type this in. I can go to the home. We can go square root of x minus 1 divided by 1 plus x, and that squared. Got that piece? Nope, no I don't. Squared. And then plus 9 cosine of x squared. 1.196. And find the acceleration vector. So a of t is equal to the derivative of this right there. That was the derivative of the position. So that's t minus 1 plus t to the negative 1. So it's 1 plus 1 over 1 plus t squared. Because isn't that 1 plus t to the negative 2? Now, the derivative was 3 cosine of t of y, right? That's up there, 3 cosine of t. So negative 3 sine of t. But we got to plug this in. But remember, that's x has the value that we want. X is holding that value. So 1 plus 1 divided by 1 plus x squared. Oh, I missed. Plus 1.191. 1.191, comma, oh, and then negative 3 sine of x. Negative 2.879. Negative 2.879. There we go. Ugh. Kind of dry math. Kind of dry. Yeah. Use a calculator. All right, I will. Find the magnitude of the velocity vector at t equals 1. Magnitude of the velocity vector. What is the magnitude of the velocity vector? What are they asking for right there? Speed. The magnitude, the length of the velocity vector. That's how fast the object is going. And then the vector has a direction also. But they're not asking about that. Find the magnitude of the velocity vector. That is going to be magnitude of v of t is equal to the square root of, I need x prime of t, which is negative 12 sine of 4t, and I need y prime of t, which is 28 cosine of 4t. So negative 12 sine of 4t squared plus 28 cosine of 4t squared. Magnitude of the velocity vector. But evaluated when t equals 1. So v of 1 is equal to square root of negative 12 sine of 4. Oh, but I need that, oh yeah, I need that squared. That squared. Plus 28 cosine of 4. squared. 20.431. Find the x and y components of the acceleration vector at t equals 1. All right, well, the acceleration vector, I need the derivative of this, which is negative 48 cosine of, right, the acceleration, cosine of 4t. And, oh boy, what's 28 times 4? 32, 3, 112? 112, negative 112 sine of 4t. There, second derivative. Negative 48 cosine of 4. A of 1, 31.374, and negative 112 sine of 4. 84.761. There we go. Now write the Cartesian equation for the parametric equation. Well, it's cosine of 4t and it's sine of 4t. Those are the same. So it's x squared over 9 plus y squared over 49 is equal to 1. It's an ellipse. Because we're taking the sine and cosine of the same thing. That's an ellipse. If it's different, then we're in trouble. Then we got to come up with something else. I think this is pretty explanatory. This one, magnitude of the velocity vector. How long is it? Well, that's Pythagorean theorem. Particle moves in the plane so that its position anytime is given by sine of 4t cosine t and sine of 2t. Find the velocity and speed of the particle when t is 5 pi over 4. Find the velocity. Well, that means the velocity vector. This is position. So first times the derivative of the second plus the second times the derivative of the first. 4 cosine of 4t. So there is the x of the velocity vector. There's the first derivative. The y is a little more straightforward. 2 cosine of 2t. And now evaluated at 5 pi over 4. So sine of 5 pi times negative sine of 5 pi over 4 plus cosine of 5 pi over 4. Yikes, times 4 cosine of 5 pi, comma, 2 cosine of 5 pi over 2. It's a mile long. But we kind of have to know where this is. Here's 5 pi over 4. And 1, 2, 3, 4, 5. Oh, I need 5 pi over 2. That's up here. Here's 5 pi over 2. The sine of 5 pi is 0, so that just became 0. I don't care what that is. Cosine of 5 pi over 4 is negative square root of 2 over 2. Cosine of pi is negative 1, so times a negative 4. And cosine of 5 pi over 2 is 0. All right, so this ends up being equal to 2 square root of 2 comma 0. So it broke down into something pretty straightforward, I think. After all that, that's what we're left with. Now here's really why we're doing it, letter B. Of course, to practice derivatives, that's nice, but B is what I was looking at here. B and C. How do we do B and C? Draw the path of the particle and show the velocity vector at t equals 5 pi over 4. We got to go back to parametric. We're bouncing back and forth today. Parametric. Y equals. Clear these out. Sine of 4t cosine of t. There's the x. Sine of 2t. And this is a really small graph. The only reason I know that is because I've done this a couple times today already. So we're going to go 0 to 2 pi. And like I said, it's a small graph. So we're going to go negative 2 to 2, negative 2 to 2. Graph. It's tiny, but it's kind of cool, I think. All right, let's sketch this thing. We have kind of this big hourglass and then this little hourglass. Something like that. I know you can do that. I know you can graph that. Really, what does letter C mean? Draw, oh, no, letter B. Letter B, we're still on B. Draw the path of the particle and show the velocity vector at t equals 5 pi over 4. So, where? Where is that? Where are we when t is 5 pi over 4? Well, we can calculate that. Second, calculate a value of 5 pi divided by 4. Way up at the top. So we're right here. Draw the path of the particle and show the velocity vector at that point right there. So it's like we have this brand new x and y axis right there, brand new. And we want to plot the velocity vector. 2 square root of 2, 0. So let's get an idea of what 2 square root of 2 is. It's almost 3. 1, 2, 3. And it's 3, it's like having the point 3, 0. So is the path moving to the left or to the right at 5 pi over 4? Well, it's moving to the right. This and the speed is the length of this right here. Right. It's moving to the right. Any questions on that? How are we doing on time? We're doing pretty good. Do not use the calculator for this problem. All right, I won't. A moving particle has position x of t, y of t at time t. The position of the particle at t equals 1 is 2, 6. And the velocity vector at any time t greater than 0 is given by this. So this is v of t. This is the velocity. That's what they gave us. Find the acceleration vector at time t equals 3. So a of t is equal to, let's keep in mind that this is 1 minus t to the negative 2, 2 plus t to the negative 2. So the acceleration is 2t to the negative 3, negative 2t to the negative 3. A of 3 is equal to 27, right? 3 to the third. And negative 2 over 27. Let's pull our maths up. Thank you. B. Find the position of the particle at time t equals 3. This is why I grabbed this one. C and D are pretty tough, but I don't know if you'll see these, but we'll do them anyway. B. Can we do B? Find the position of the particle at time t equals 3. And they told us where we're at 1. So we are going forward with this one, which is good. We're not going backwards. So we have the x-coordinate will be 2 plus the integral from 1 to 3 of 1 minus, let's call it t to the negative 2 dt. So there, right there, and we grab that value, that 2 over there. 6 plus integral from 1 to 3 of 2 plus t to the negative 2 dt. There we go. That's going backwards, from velocity back to position. And they went nice and forward for us. All right. We kind of already did something like this. Let's go t, what would that be? Plus t to the negative 1, from 1 to 3? Yeah, because you'd multiply by negative, reduce the power by 1. 6 plus 2t minus t to the negative 1 from 1 to 3. 2 plus 3 plus 1/3 minus 1 plus 1. Did I need that? Yeah, okay. Got that. 6 plus 6 minus 1/3 minus 6 minus, no, not 6, excuse me, 2. Plugging in 1 now. 1 minus 1. Something like that. 5, 15/3 plus 1/3 is 16/3 minus, oh, no, that didn't work out right. 15/3 plus 1/3 minus 2. 6/3, 10/3. 12, 36/3 minus 1/3, right? Because then it's minus 0. 30, I'm getting 35/3. I hope that's right. C and D. All right, here we go. They're not, mathematically, they're not tough, but just knowing what to do is a little tough. For what time t greater than 0 does the line tangent to the path of the particle at x of t, y of t have a slope of 8? Have a slope of 8. Well, the slope is still dy dx. That doesn't change. That doesn't ever change. It's always dy dx. But they gave us they gave us velocity, didn't they? That is dy dx right there. So 2 plus 1 over t squared over 1 minus 1 over t squared. Don't they want to know where that is 8? Where's the slope 8? So we'll set that equal to 8. Well, let's get rid of the complex fraction. Multiply everything by t squared. So the top and bottom anyway. So 2t squared plus 1 over t squared minus 1 is equal to 8. So there we go. We got rid of the complex fraction. That's a good step forward. Multiply over the denominator. Well, now we're kind of good to go. We got 1 is equal to 6t squared minus 8. 9 is equal to 6t squared. T squared is 9/6, 3/2. So t is whatever square root of 3/2 is. That's where the slope is 8. And then D. I'll come back down to this. The particle approaches a line as t approaches infinity. The more and more we go to the right, the more this curve is approaching a line. It's becoming linear at the end. That's what they're saying. So what is the slope of that line that it's approaching? So we have the limit as t approaches infinity of, where's the slope? The slope's right here. Here's the slope. That doesn't change. So the limit as t approaches infinity is approaching this slope right here. So 2 plus 1 over t squared over 1 minus 1 over t squared. So that's the tough part, knowing what to do. Plugging in infinity, well, these two little fractions, they just become 0. So 2 over 1. The computation is easy. Knowing what to do is a little harder. Let's pull up our mass. Thank you. Any questions on this? All right, no TA today. 23. All right, we might be able to finish this. If x and y equal that, find the equation of the line tangent when t equals 1. We need a point. And we need a slope. Need a point and a slope. So we plug 1 in, we get 2. Plug 1 in here, 9. Square root of 9 is 3. So 2, 3. But now we need the slope. We need dy dx. That never changes. No matter what derivative we're taking, it's dy dx that we're looking for. But this is dy dt over dx dt. So this is really dy dt over dx dt. So the derivative of y, 2t plus 7 to the 1/2. That's 1/2. 2t plus 7 to the negative 1/2. But then times 2, times the derivative of the inside. So the 1/2 and the 2 cancel, and it's 1 over square root of 2t plus 7. dx dt, 2t plus 1. There we go. Now we just have to evaluate this when t is equal to 1. So 1/3, right, and square root of 9 over 3, which is 1/9, because we can multiply the top and bottom by 3 on this. There's 1/9. So the slope, 1/9. So the final answer, y minus 3 is 1/9 times x minus 2. Second derivative of this. dy dx is 4t to the third over 6t squared. So it ends up being 2/3 t. So it reduces to something pretty simple. Now the second derivative. d2y over dx2. Easy, no problem, 2/3. Problem with that? Yeah, you got to put it over dx dt again. So don't get caught by that. I told you we'd review it, a couple times before the test. Here's one time. Over 6t squared. So that's 2 over 18t squared, 1 over 9t squared. There we go. So don't get caught. Second derivative, got to divide by that dx dt again. It's really easy to forget that. What is the length of the curve from 0 to 2 in the previous problem? Right here, from 0 to 2. We'll just set it up. Integral from 0 to 2, square root of, I need the derivative. Derivative is 4t to the third. 4t to the third squared. Need the derivative. Oh, yeah, that's dy. I just did, wait. 4t, I did dy. And then I need this other one. 6t squared squared dt. There we go. Am I good? Bored but good? Yeah. Let's see how much of this we can do. If s of t is that, v of t is what? This is just practicing derivatives more than anything. V of t is 1 over 3t squared minus 2t, but then multiply times the derivative of the inside. There we go. And 9t squared is the y. So we got 12 minus 2, is that 10? And 12 minus 4 is 8, so 10/8 and 36. And if you want to reduce it, 5/4, 36. Find the magnitude of the velocity vector. Find the speed. V of t is, oh boy, derivative of cosine is negative sine. But then if I multiply by pi over 2 to 4, isn't that 2 pi? Right? 4 over 2 is 2. Multiply derivative of the inside. And then we have cosine of pi over 2t, right? But then multiply times the derivative of the inside is 7 pi over 2. Evaluate when t is equal to 3. Negative 2 pi. What's the sine of 3 pi over 2 is 1. So negative 2 pi. 7 pi over 2. The cosine of 3 pi over 2 is 0. 0. The acceleration vector. We got time to get this done. Derivative of sine is cosine. But multiply times the derivative of the inside. Multiply pi over 2 times pi. What, negative pi squared? Negative pi squared. Derivative of cosine is negative sine. If I take pi over 2 times 7 pi over 2, that's 7 pi squared. 7 pi squared over 4. Evaluate when t is equal to 3. Cosine of 3 pi over 2 is 0. Yeah, so this is 0. Sine of 3 pi over 2 is 1. So negative 7 pi squared over 4. And finally, find the equivalent Cartesian equation. X squared over 16 plus y squared over 49 is equal to 1. Because it's the cosine and the sine of the same thing. So it's pretty straightforward when that happens. We made it. We made it.